Hello friends, how are you? I hope you all are keeping well. Today we are going to start the second part of exercise 6.3. And in this part we will do some of the applications of square and square roots. And after having these applications or these video lessons, you would be able to solve the similar kind of problems in your normal life. So let's begin. Today we are going to start the second part of exercise 6.3. Here we are with our very first statement. For each of the following numbers, find the smallest whole number by which it should be multiplied so as to get a perfect square. Also, find the square root of square number so obtained. Our first number is 252. First of all, we will find the prime factors of 252 by the same method we have learnt in the previous lecture. Here we will find out the smallest number with which 252 is divisible, as we can see that it is divisible by 2. Sorry. Dividing 252 with 2, we get 126. It is again divisible by 2. Dividing it with 2, we get 63. 63 is divisible by 3. We get 21. Dividing 21 with 3, we get 7. 7 is divisible by 7 only. So, dividing 7 with 7, we get 1. Now, the prime factors of 252 are 2 multiplied by 2 multiplied by 3 multiplied by 3 and multiplied by 7. Now, the next step is to make the pairs of same numbers. Oh, here the number 7 is alone. How can we make it a pair? Yes, it's simple. By simply multiplying it with 7. As you can read the statement that which smallest whole number should be multiplied to make it a perfect square. Please pay attention to the word multiplied. So, here we will multiply the given number with 7 because we have to make the pair of 7. Now, multiplying 252 with 7, we get 1764. 1764 is a perfect square since all the prime factors occur in pairs. Now, we are asked to find out the square root of this number also. Now, the square root of 1764 is equal to under root of all the prime factors of 1764, making the pair of same numbers. and choosing 1 from each pair. We get 2, 3 and 7. Multiplying these numbers, we get 42. Means that the square root of 1764 is 42. Moving to the next question. For each of the following numbers, find the smallest whole number by which it should be divided. Here in the question is divided, so as to get a perfect square number. Also find the square root of the square number so obtained. Here we have to pay attention on the word divide. Earlier we have multiplied 252 with some number, but now we have to divide it by some number to make it a perfect square. Now we already know the prime factors of 252. Making the pairs of same numbers, we get 7 as a single number. Now because we have to divide 252 with some number to make it perfect square, so we need to eliminate 7. How can we do that? Simply by dividing it with 7. Seven cancelled with 7. We get 2 multiplied by 2 multiplied by 3 multiplied by 3. So we need to divide 7 to make 252 a perfect square. Multiplying these terms, we get 36 as the perfect square. We are also asked to find out the square root of 36. Now the prime factors of 36 are 2 multiplied by 2 multiplied by 3 multiplied by 3. Making the pairs of same numbers and choosing one number from each pair, we get 2 multiplied by 3. Multiplying these, we get 6. Means the square root of 36 is 6. Let us try one more example and try to understand in a better way. This time we have 768 as our number. Finding the prime factors of 768. First of all, we will divide it with 2. We get 384. Again dividing it with 2, we get 192. It's again divisible with 2. We get 96. Dividing 96 with 2, we get 48. Dividing 48 with 2, we get 24. Dividing 24 with 2, we get 12. Dividing 12 with 2, we get 6. Dividing 6 with 2, we get 3. Dividing 3 with 3, we get 1. So, the prime factors of 768 are 8 times 2 multiplied by 3. Let us make the pairs of same numbers. Oh, 3 is not the pair. So, to make it pair, what can we do? We need to multiply it by 3 because in our question we are asked that the smallest whole number by which it should be multiplied. So, to make the pair of 3, we will multiply this number with 3. Now, multiplying it with 3, we get 768 multiplied by 3 is equal to 2304. Now, this is the perfect square number. And 3 is the smallest whole number by which 768 should be multiplied to get a perfect square. Now, the prime factors of 2304 are 8 times 2 multiplied by 3 multiplied by 3. Square root of this number is equal to the square root of all the prime factors, making pairs of same numbers and picking one from the pair. We get 2 multiplied by 2 multiplied by 2 again multiplied by 2 and multiplied by 3. Multiplying these numbers, we get 48. Means the square root of 2304 is 48, which is the required perfect square number. Now, we will try the same number in the second way, where we are asked to find the smallest whole number by which it should be divided to get a perfect square. Now, we already have the prime factors of 768. Now, we can see that 3 is not in the pair. So, to make it a perfect square, we need to divide it with 3 because we have to eliminate this 3 because it is not in the pair. So, we will divide it with 3. 3 cancel with 3. We get 8 times 2. Multiplying all of them, we get 256 as the required perfect square. Now, to find the square root of 256, we will write down the prime factors of 256, making pairs and picking one number from each pair, we get 2 multiplied by 2, multiplied by 2 and multiplied by 2. Now, we need to multiply all these. We get 16 as our answer. Means the square root of 256 is 16. And the smallest number with which we need to divide the number, that was 3. Now, let us move on to our next question. Our statement says 2025 plants are to be planted in a garden in such a way that each row contains as many as plants as the number of rows. Find the number of rows and the number of plants in each row. Now suppose, just for imagination, we have 4 rows. According to our question, we have 4 rows
plants
in one row. If we have 5 rows, then we have 5 trees in one row or 5 plants in one row. But in actual, we don't know the number of rows and plants. So, let us suppose that
number of plants is
Z. Let us suppose we have Z number of rows. Since the number of rows and number of plants in one row are equal, it means the number of plants in each row is also Z. So, total number of plants will be Z multiplied by Z. Number of rows multiplied by number of plants in one row. So, the total number of plants will be Z multiplied by Z. We can write it as Z square. We are given that total number of plants are 2025. Means Z square is equal to 2025. Now Z is equal to square root of 2025. Now we will make the prime factors of 2025. Dividing it with 2, we get 675. Dividing it with 3, dividing it with 3, we get 675. Again dividing it with 3, we get 225. It's again divisible with 3, we get 75. Dividing it with 3 again, we get 25. 25 is divisible with 5, we get 5. 5 ones are 5. So, we get the prime factors of 2025 as 4 times 3 multiplied by 5 multiplied by 5. Making pairs and choosing one from each pair, we get 3 multiplied by 3 multiplied by 5. That is equal to 45, which is the required number. Means we have 45 number of rows of plants, and each row has 45 plants.
So guys, it's all for today. With this, we have completed the exercise 6.3. I hope you must have understood the concepts. Now, I have some homework for you. Please give this a try. Let me read it for you. The student of class 8 of a school donated rupees 2,401 in all for Prime Minister's National Relief Fund. Each student donated as many as rupees the number of students in the class. Find the number of students in the class. First of all, give it a try, then check its answer. So students, thanks for today. Thank you so much for watching this lesson. Bye-bye and take care. Keep growing, keep learning. Bye-bye.